Let's talk about sharding. So sharding is a database partitioning technique where large datasets are divided into smaller, more manageable pieces called shards, each of which is stored on a different database server. This is primarily done to improve the system's scalability, performance, and capacity by distributing the load across multiple servers. Each shard contains a subset of the total data, and the combined shards represents the entire original dataset. And there's two main types of sharding. There's vertical sharding and horizontal sharding. Let's start by talking about horizontal sharding or horizontal partitioning. So in horizontal sharding, the data is split across multiple shards based on rows. So each shard holds a subset of the table's rows, but each shard has the same schema and set of columns. So different rows are distributed across different servers. And this is how it works. So we have rows distributed based on some criteria. For example, ranges of a primary key. So an example of this would be user IDs from 1 to 1000 in one shard, or in this example, accounts A to M in one shard, and user IDs 1001 to 2000 in another. So in this case, we have accounts A to M in this shard and accounts N to Z in this shard, and they live on two separate database servers, in this case, MySQL databases. And continuing this example, if you have a table of users, horizontal sharding might divide the users such that we have users 1 to 1000 on this server, or users 1001 to 2000 on this separate server. And the use case for horizontal sharding is that it's ideal for large-scale applications where a table's rows grow very rapidly. For example, user-based applications such as social media or e-commerce. And some of the advantages of horizontal sharding include improved write performance. Since each shard handles a portion of the write operations, it reduces load on individual shards. It also improves scalability because you can add more shards easily as the data grows or the number of rows in the table grows. There's also easier distribution of data, so you can spread data across multiple physical machines. Now let's talk about vertical sharding or vertical partitioning. So in vertical sharding, the data is split by columns instead of rows, as the name suggests. And each shard contains a subset of the table's columns, meaning that different attributes of a record or different columns are stored in different shards. And how does this work? So different shards hold different columns of the same table. For instance, one shard could hold basic information like name and email, while another shard might hold information like password and credit card info or other sensitive data. So let's say in a user table, one shard might store personal information like the user ID, name, and email, while another shard might store more infrequently accessed data, let's say the bio, the profile picture, etc. So this is useful when different parts of a data set have different usage patterns or scaling needs. For example, let's say this blue shard here contains very frequently accessed user information, and then this red shard over here contains very infrequently accessed data. So based on the usage patterns, we might want to distribute this original table into different shards. So what are some advantages of this? We have optimized queries. So by storing only the frequently accessed columns in a shard, you can improve the read performance. And we also have improved security. So sensitive data can be stored in a separate, more secure shard.